So this lesson is on the concepts under sections 9.1 and 9.2. We're going to talk about wave interference first, and then we're going to lead into standing waves, which is the end of 9.2. First thing is a conceptual idea here. If you look at the picture here, what we have is a particle that's part of a medium, and we have forces that are applied as part of the wave. So these would be transverse forces causing a transverse wave, which makes the medium vibrate perpendicular to the direction that the energy is being transferred. So if you imagine, when a wave is transferring through a medium, the force is pushing particles up and down. So when the force reaches the particle, let's group that back together again. When the force reaches the particle, it pushes the particle away from its rest position. Of course, once the force goes past, it's no longer affecting the particle. There's another force pulling the particle back to where it wants to be. It wants to be in that rest position, so it comes back down. So the effect is the force goes through the particle, and while it's going through the particle, oscillates in that direction. That force in a transverse wave is occurring because the particle before it is moving in that direction and pulling it up that way. Similarly, if the force is acting downwards, in the opposite direction, when it goes through, it forces the particle to go the other way. And of course, the net result, because in a wave we have upwards forces and downwards forces passing one after the other, the particle oscillates up and down as long as that force is being applied, or those forces are being applied, as long as the wave is traveling through. Now, when we get into interference, let's place the particle on its rest position. If you have two waves approaching that particle from opposite directions, then what happens is, as they approach, if the one, let's get that F out of the way, as the one force approaches, it would push the particle in that direction a certain distance. The other particle, or the other wave force, when it reaches, it pushes the particle in the same direction. So the particle ends up going twice as far as it would if only one of those forces came through. That's what we call constructive interference. It's not necessarily twice as far unless the two waves are identical. So constructive interference, two waves encounter collide with a particle with a peak at the same time. And the result is the particle goes further and you end up with a larger amplitude wave. Now to reverse this situation, we can do the opposite. Each wave, or each force, each wave can be acting in opposite directions when they reach the particle. So we have a force pushing the particle upwards, or to one side, and another force pushing the particle in the opposite direction. Well, when you have two forces that are balanced and opposite, they cancel each other out. So the result is the particle just stays where it is. So we have two situations here. We've got one situation where the two forces, or two waves, are working together in the same direction to construct a larger wave, a larger amplitude. We call that constructive interference because it's constructive, it's building something. And we can have two waves that are going the opposite direction. And basically what happens when they encounter the particle at the same time is they destroy each other. So we call that destructive interference. So there's the first one. The next concept is the idea of visually adding two waveforms as they approach each other. So that's what we're going to do now. This is probably going to take up the rest of this video. So there might be two. I have no idea why that's giving me opposite numbers. Okay, so here we go. If these two waves, if the first wave, this triangular wave, was traveling to the left, and the rectangular wave was traveling to the right. We won't deal with these kinds of waves in this course, but they're easier to visualize when we put them together. What we have to do to draw the resultant wave is we have to imagine these waves adding together. So the horizontal line here, this is the sort of dead zone, the rest position. The wave is not doing anything here. It's only in this active portion that the wave is actually doing something. So when you're adding these waves together, if you put the two dead zones together, nothing's happening still. So the easiest way to think of this is, as they pass through each other, they add to each other. So until we get to this point, when they're sliding across like this, until we get to this point, we see nothing different. We just see a rectangle traveling towards a triangle, and vice versa. But once they start to cross, their effects add together. So let's go here and draw what we would see in the actual wave at this point. So at this point, when the waves are crossing each other at this point, if we wanted to draw the effect, we would trace along the line. Along here, nothing's happening. At this point, it's only the square wave that's acting on this portion, up until there. And the other opposite, coming from the opposite side, the flat dead zone, the triangle, and up until this point, it's just the triangle. But in between, when the two of them are together, we have to add them up. So, for example, if we were to take right on this vertical line here, this portion here has to be added, because that's the height that the triangle is adding on to the rectangle. So we have to move that up to here. So at this point, the wave jumps straight up to there. And then, as we go through this region here, the triangle is coming down, but it's inside the rectangle, the line is going to come down there just the same. So our resultant waveform, let's see if I can pull the waves out, looks a little bit like that. So that's kind of weird looking, isn't it? But that's what the waveform is going to do. When the two waves pass through each other, they're going to constructively interfere with each other to cause that effect.
Just a reminder of the IT Learning Team meeting in T119. It's happening in a couple minutes. See you there. Bye.
I'm going to make these a little bit bigger so it's easier to see. And I'm going to push them a little more together. Let's imagine they're sitting right here. So we're kind of at a boundary point. The boundary points would be when the triangle first touches, and as they're crossing like this, nothing changes. When they get to here, something's going to change, because now the triangle, instead of adding, is going to be subtracting. It's going to be reducing. So the value is going to go down at that point where they first started impacting. So let's toss it somewhere in the middle. Let's put it right there. If we want to trace this effect, of course, here we have a dead zone. Nothing's happening. But now we shoot up to this point, and then we add the triangle on top of that. So there's that. And the triangle decreases, and then suddenly the square is gone. So we're above the square now, so we have to drop right down to this point. And then from here on, it's just the triangle, and we follow that out. So again, pull the waveform out, waveform's out. There's our resultant waveform at that moment. And that's how we add waves to show a visual of constructive interference. Destructive interference would be the exact opposite. So let's just wipe this bit out here. Reverse this. Now let's add those together. So when they add together, nothing happens here, and then once the two waves start to impinge on each other, one subtracts from the other one. So while the square wave brings us up to here, the rectangular wave brings us down by this much, so we're going to end up about here. So we're going to follow the waveform. It's going to be triangle here. We're going to come back down, and then we're going to jump up where the rectangle has us. Now like that. So triangle taking us back, across, down, and over. So we have some destructive interference happening in this wave, and that's what it'll look like. Okay, I'm going to stop the video here. I'll start it again for standing waves. Let's just have a quick look at what's next on the page. Yeah, we'll do standing waves for the rest of this, or the next video.